morning, students. Yeah, welcome to the Lakshya online classes. Today, this is the physics class, and some of the students and commented that it is better to post that recording lessons. So that's why today we are trying to upload a recording video lesson. Okay, and yesterday and day before yesterday we discussed about units and dimensions, and yesterday we focused on rounding of the numbers. So in this lesson the last topic is error analysis. So today we focus on that error analysis. Okay students, better to arrange pen and paper. After completing that concept, we will do some of the problems. Okay, error analysis. For example, the length of the pen. The length of the pen I measured n number of times. The first measurement is A1 and the second measurement is A2. Third measurement is A3, so on AN. So I measured the length of the pen n number of times. Those individual measurements are A1, A2, A3, so on AN. These are the n measurements. So in your mathematics or lower standard, you aware of that mean value, or otherwise in 10th class you have the marks in different subjects and the average mark. How do you calculate the average mark? Obviously, sum of the items by number of items. I mean that some total marks by number of subjects. So from these measurements we can calculate the mean value. Mean value is denoted by AM. This is also called as average value. AM equal to sum of the items by number of items. Sum of items A1 plus A2 plus so on plus AN divided by N. This is the mean value of all the measurements. Why? What is the advantage to calculate the mean value? So maybe by measuring the length of the pen, we may get that error. Errors are of different types. Okay, man-made errors or instrumental errors, whatever may be, or surrounding errors, errors due to surroundings, whatever may be. So to minimize the error, we can calculate the mean value. This is the mean value or average value. Average value AM equal to A1 plus A2 plus so on AN by N. Yeah, we get the mean value of the length of the pen. Okay, the first measurement is A1. Maybe in the first measurement there may be error. And AM greater than A1 or AM less than or A1. So based on that, the error may be positive or negative. So that error is called as absolute error in the measurement A1. Absolute error. Absolute error in A1 is denoted by delta A1. delta A1 equal to AM minus A1. Like that, absolute error in A2 is delta A2 equal to AM minus A2, or absolute error in A3 is delta A3 equal to AM minus A3. So all these delta A1, delta A2, delta A3, so on delta AN are the absolute errors in the measurements A1, A2, A3 and so on. These absolute errors may be positive or negative. Okay, if AM is greater than that of the measured value, absolute error is positive. If AM is less than the measured value, absolute error is negative. Okay, so absolute error. Yeah, delta A1 is absolute error in A1. Delta A2 is absolute error in A2 and delta A3 is absolute error in A3. So on, delta AN is absolute error in AN. So from these measurements, from these values, we can calculate the mean absolute error. Mean, next third concept, mean absolute error. Mean absolute error. Mean absolute error is delta A bar equal to modulus of delta A1 plus modulus of delta A2 plus so on modulus of delta AN by N. This is mean absolute error. Mean absolute error. So mean absolute error is the sum of the items, sum of the absolute errors by number of absolute errors. So delta A bar equal to modulus of delta A1 plus modulus of delta A2 plus modulus of delta A3 and so on by N. This is mean absolute error. Okay, next one is relative error. So from the mean absolute error, we can write the value as A equal to AM plus or minus delta A bar. This is the measurement. Started. So the mean absolute error, from the mean absolute error, the measurement A equal to AM plus or minus delta A bar. Okay. Next, relative error. Relative error or fractional error. Relative error is also named as fractional error. Okay, relative error is nothing but the ratio of mean absolute error to the mean value. mean absolute error to the mean value. Next, percentage error. Percentage error is delta A bar by AM into 100. So absolute error, mean absolute error, and relative error, and percentage of error. Okay, while doing the measurements, while calculating the measurements, we may get the errors. So our next topic is propagation of errors. Propagation of errors. For example, in the case of propagation of errors, the first case is if the error in some of the quantities, consider a measurement x is measured as a plus b, x equal to a plus b. Here delta a is absolute error in a, delta b is absolute error in b, delta a is absolute error in a, and delta b is absolute error in b. So the absolute error in x can be written as delta x equal to delta a plus delta b, or it can be written as plus or minus. The absolute error in x is delta x equal to delta a plus delta b. Okay, so from this we can calculate the percentage error in x. So delta x by x into 100 equal to delta a plus delta b by x into 100. In the place of x, we can substitute the value a plus b. Next, if the second case, case b, if the measurement is expressed as x equal to a minus b, in this case also we consider the absolute errors. So if delta a is absolute error in a and delta b is absolute error in b, the absolute error in measurement x can be denoted as delta x. Delta x is nothing but plus or minus delta a plus delta b. So from this we can calculate the percentage error in x. Next, the third case, if the measurement is expressed as x equal to a into b as a product. In this case and division case, we consider a relative error. Okay, so the relative error in x is given by relative error in a plus relative error in b, or percentage error in x is given by delta x by x into 100 equal to delta a by a into 100. It means that percentage error in a plus percentage error in b. And if the measurement is in the form of a by b, that is fourth case, x equal to a by b, in this case also we consider relative error only. So in the case of multiplication and division, we consider relative errors. In the case of addition and subtraction, we consider absolute errors. So here the relative error in x is relative error in A plus relative error in B. So percentage error in x is delta x by x into 100. This is percentage error in x equal to delta A by A into 100 plus delta B by B into 100. This is percentage error in B. And the last case, if the measurement is expressed in terms of E case, x equal to A power m into B power n, like that. So here the relative error in x is given by m times of relative error in A plus n times the relative error in B, or the percentage error in x is equal to m times the percentage error in A plus n times the percentage error in B. So these are the 5 possibilities while measuring a physical quantity. Okay, this is the concept of propagation of errors. After that, and we switch over to the sum of the problems. Okay, I give 2 or 3 problems, and first one, a physical parameter A can be determined by measuring the parameters B, C, D and E. A physical parameter A can be determined by measuring the parameters B, C, D and E. A can be determined by measuring the parameters B, C, D and E, and the relation is given as A equal to B power alpha into C power beta divided by D power gamma into E power delta. This is the relation. A equal to B power alpha by B power alpha into C power beta divided by D power gamma into E power delta, and maximum error in B is B1%. Maximum error in B is B1%, and maximum error in C is C1%, and maximum error in D is D1%, and maximum error in E is E1%. Then maximum error in the measurement of A. We have to find out the maximum error in the measurement of A, and this is the relation given. Okay, from our fourth one we can write the percentage error in A is equal to alpha into percentage error in B, that means delta B by B into 100 plus beta into delta C by C into 100, I write here, plus gamma into delta D by D into 100 plus delta into delta E by E into 100. So which is alpha B1 plus beta C1 plus gamma D1 plus delta E1. So the maximum percentage error in A is alpha B1 plus beta C1 plus gamma D1 plus delta E1. Okay, I give another problem. I give another problem. The pressure on the square plate, is measured by measuring the force and the length of the sides of the plate. Maximum error in force is that means delta F by F into 100 is given as 4%. This is maximum percent in force, and maximum percent in length is given as 2%. What is the maximum percentage error in P? Okay, so from this pressure equal to force by area, so force equal to F by L square, because it is a square plate, area of the square is side into side. I write down as length into length. So from this the percentage error in the maximum percentage error in P is delta F by F into 100 plus 2 into delta L by L into 100. So this is given as 4% and this is given as 2%. So 2 into 2, 4. So the maximum percentage error in P is 8%. Okay students, I have given 2 examples, and already I sent that PDF file of units and measurement. Please go through that. If you have any doubts immediately, you just message me. I clarify your doubts. Okay, all the best. Thank you.